So this is the class tree, and yeah, there are some codes that I already explained in the PPT, in the PowerPoint, and it contains all the method element, equal, not equal, okay, and then we have root, parent, number of children, length, and so on. Yeah, the author of the book already create this tree, and you can use it if you need this tree to do some kind of problem solving in your algorithms or in your team project. Okay, so they already provide this code, and you can just reuse it. If you think that you need to use binary tree, or if you need to use tree, yeah, this is the code that you can use. Okay. So I will continue to the next section, which is about the priority queue. So this is a kind of sequence. Okay? After we learn about the stack, and then I will learn about the queue, and then we learn about the linked list, single linked list, double linked list, and then we continue to the tree. So this is the continuation of the tree. We call it, this is the priority queue. So the priority queue, we will learn at least three things in this slide. We will learn about the priority queue ADT. This is the abstract data type. And then sequence-based priority queue and priority queue sorting. So what is priority queue ADT? The priority queue is similar with queue. You still remember queue? In the mid-exam, yeah, you learn about the queue. The queue concept is first in, first out. Okay. You still remember? FIFO. Okay. First in, first out. Now, we want to put priority. Why? The priority queue, the idea is similar with the, for example, I forgot. Do you know about the concept of the queue in the Avalanche? Have you ever visited Avalanche? If you go to Avalanche, if you visit some attraction, and if there are many queues, for example, safari or something like that, if there are many queues, yeah, you need to wait for a long time. But there will be some cases or some events you will get the pass. So you can have the pass maybe because you are having your birthday, or maybe you are, for example, the Jangain, you will get some special pass, okay? Or if you are using your wheelchair, then you can pass. So that kind of queue, we need to put a kind of priority. Yeah. So that kind of priority, we want to put a value, so this value will be first compared to the other values. That's what we can say about the priority. So how this priority will work in this kind of data structure. So the priority queue is, okay, the same with the other kind of data structure. We will store a collection of items. And now we need to understand that this item contain of two attributes. The first is key and the other is value. There are two main methods in the priority queue. We will add, so we want to add something. Okay? What is something? We want to add the K. The K is the key. And then we want to add X. X is the value. So, for example, you want to add a person into one queue. Okay? And then we want to remove min. Remove min, it means the smallest key. So let's maybe assume that the smallest number is the higher priority. Okay. We have additional methods like minimum. So I want to know what is the most minimum value. We want just to know what is the smallest key, but not remove. Okay. Returns, but does not remove an item with the smallest key. We want to know the length of the priority queue, which is P, and we can also check whether it is empty or not. Yeah, some application standby flyers. Yeah, that's also one application. Or auctions. Do you know auctions? I think in old days, you have auctions. So you want to sell something, and then you want to bid. If your price is higher than the others, then you will have the priority to get the item. Okay. So that kind of things is kind of priority queue. Stock market. Okay, so if you want to buy some stock and then you already buy some of the stocks and you are in the queue, but if you buy a higher lot or a higher number of the stocks, maybe you will get the priority. So something like that. So, okay, this is one example. Okay, we start with P. P is an empty priority queue. And then we want to add what is this one. We have the key is 5, and then A is the item. Okay, so we want to add 5, which is the key, and then A is the item or the value. Okay, and then the result in the priority queue will be 5, A. Next, I want to add another value. I want to add C. Okay, so I want to add the key equals to 9, and then I want to add C as the value. Yeah, in this example, the smallest number means the higher priority. Okay, so it depends on the problem, because this one, the smaller number is the priority, then the smaller number 5, it is in front. The higher number will be at the end. So when we have 9C, when we have 9, C, so 9, C will be at the end. Now we have a priority. So we put a lower number 3 for the value P. Then 3 will be in the first part. Okay. And then next is 5, and then next is 9. So we want to know the highest priority based on the list number. And then we have 7. Okay, then we need to find where is the location of 7. Because we already have 3, we have already 5, we have already 9, then 7 will be in the mid of 5 and 9. Okay. So the value is only the value, but this priority queue has the highest importance on the number. Okay. So the number, the key, is important to build the priority queue. And then if I want to check what is the minimum is 3, P. Okay, based on this last one, this is the minimum. And then I want to remove the minimum, then yes, 3, P will go first or will be removed first. And then I want to remove the minimum, okay, 5, A, because this is in front. It will be removed first. And then I want to know the length of the P, because there are 2 elements, then I can just say 2. I want to remove the minimum, then 7 will be removed. I want to remove the minimum, and the 9 will be removed. So if it is empty or not, yes, because there is no element, then it is true. If I want to remove the minimum again, it will be error because there is no value. Okay. So in the concept of priority queue, the key is important. Okay. The key is important. So whenever you create a key, it can be an arbitrary object on which an order is defined. So when you say that, okay, I want to put the key equals to 5, okay, and then you cannot create the same number of key because it is key. And if you put the same number of key, you cannot distinguish where you should put this number. So the key should be distinct. Okay. So two distinct entries in a priority queue can have the same key. Oh, what does it mean? Okay. So if it is the same key, then you need to understand the mathematical concept behind this total order relation. Because this is total order relation with the symbol, this one, less than equal, we have three properties for the mathematical concept. We first have the reflexive property. X is less than equal to X. Okay. It means if you have like 5 comma A, okay, and then if you have 5 comma B, okay, so actually it is still allowed in the priority queue. So in another data structure, it is not allowed, but in the priority queue, it is allowed. And in this case, you will see this is the reflexive properties. So 5 is less than equal to 5. So it means it is the same value, X. And there is an anti-symmetric property. It means if X is less than Y and Y is less than equal to X, then X equal to Y. Okay, it means you will not have the value higher or lower, and if the value is following with these properties and following these properties, then the value will be the same. Okay, and then the last one is transitive properties. If X is less than Y and then Y is less than Z, okay, X is less than equal to Y and Y is less than equal to Z, then X will be less than equal to Z. Okay. So we have three properties: reflexive property, anti-symmetric property, and transitive property. I also give you the code in e-class, so you can check the code. Okay. In the code, we will have the key and value. We will have the key and value. And the priority queue store items to allow for efficient insertion and removal based on keys. If you have only lists, if you have only arrays, yeah, you will insert, remove, and you do not know what is the element in which location. But if you know about the priority queue, if you want to check, okay, this item should go first, this item should go later, then you need to use the key. And this key can be done with the priority queue. So in the priority queue, when we create a class, so there are keys and values. So we need to define the K, we need to define the P, and then, yeah, less than. So it will compare the item based on their keys. Okay, so we will check for every key. So this is empty. We want to check whether it is empty or not. Okay. And so on. You can check on the code that I share on the class. Sorry. Oh, you cannot hear my voice. Okay, let me check. So,
No, it's okay.
it's okay. Oh, okay. Because yeah, one student mentioned that my voice is not clear. Okay, yeah. Anytime if you have any issues with my voice or something, please let me know, because I cannot check my own voice. Okay. Okay, then I will continue. So Kim Juyeon, is it okay now? Hello, hello, testing. I'm not sure whether this is about my network or your network. Okay, but I'm recording this lecture, so if you need to review the lecture, I will upload the video and the e-class later. Okay. Now there are two types of priority queue. Okay. The first type is unsorted list, and the other type is sorted list. Okay, what does it mean? So let's check one by one. Unsorted list. When we do with the unsorted list, means we will just put the value, 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 and then we will sort. Okay. So we will not do the sorting when we insert. So you can see here the performance of the add is inserting a new value is O1, since we can insert the item at the beginning or at the end of the sequence. So every time you input, you insert, then yeah, you don't think that this will be affected. You can just put in front, or you can just put at the end. However, when you want to remove the minimum, and if you want to check the minimum, it will take ON. Why? Because you need to sort first. Okay. After you sort, and then you will remove the minimum. So it will take ON to check where is the smallest key. Okay. That's the first about the unsorted list. However, we can use the sorted list. Okay. The sorted list means whenever we have a new value, we will directly sort. So when you add, it will take ON time, since we have to find the place where to insert the item. So for example, yeah, I will show you the example with some code later. So if we do with the remove min, if we do with the minimum, it will take O1. Because the smallest key is always at the beginning, because you always sort the item first. Okay, let's see. This is the code. Okay, this is the unsorted priority queue. And then you have the method find minimum. What is find minimum? Yeah, I hope that you can learn by yourself about this unsorted list implementation. As I know from your proposal, some of you may use this kind of implementation. I'm not sure. Team number 8 or team number 7, you want to use the and I forgot. So you want to sort. After you sort, then you will do something like the finding the shortest path problem. Okay, so this kind of priority queue can be also work for your project. Okay. This is the code for the sorted list. Okay. So the idea is the same, but when we do with this add, okay, if you check the add section here, you can just add the value. You can just add the value because it is unsorted, so you just add the value after the next after the last item, and then when you want to find the minimum or when you want to remove the minimum, okay, so you need to run the find minimum. What is find minimum? Here is the find minimum. So the find minimum, yeah, it will check whether it is empty or not. If it is empty, then yeah, you need to print it is empty. If it is not, then you assume that the smallest one will be the first data, and then walk. So we want to go for every element of the data. And then when we have run for every element, so it means if we have n data, it will work for n times. Okay, so we have one loop. So if we have one loop, it means the maximum of running time will be on. Yeah, many of you did correctly on your exam. Like we have the Euclidean distance, and you have the Manhattan distance, and the big O notation is On. But I don't know why some of you put the On power of 2. Yeah, even though you have On, but you put the On power of 2. And you can see some of the exam choose the O1. So I hope by now you understand what is the difference by O1, the constant, On, okay? And hopefully you can make your own algorithm to optimize the existing algorithm. For example, if some of you did the Dijkstra algorithm, okay, some of you try to adopt the Dijkstra algorithm. So the Dijkstra algorithm is basically On. So how can you optimize On to O log n, for example? Okay, hopefully you can do that one. Okay, this is the On case because we have one loop and we will do for every element. In the case of sorted list, we have constructor. Okay, you can see here we use the positional list. The positional list is the list that we already learned before. And then we just want to know the length and we want to add, okay. When we add the new value, okay, here, we will check. Let's see the newest, and we want to assign the key and value, and let's say the last data. So when we have the last data, and then I would like to check if the walk is not known and the newest is less than the walk element. It means the newest value is less than the last element. Then it will always move to the lowest one. If it is known, then yeah, go to add the first. Or if not, then it will go after. For the minimum, then because it is a sorted list, you will just check whether it is empty or not. If it is empty, then give the exception. If it is not empty, then you can just get the first data. The same with the minimum. You want to remove minimum, you just check whether it is empty or not. If it is empty, then you will just give the exception. If it is not empty, then you will just delete it. Okay. So this is the algorithm. Okay. We call this is PQ sorting. When we use this PQ sorting, we want to insert the element. Okay? We want to insert the element one by one with a series of add operation, and then remove the elements in sorted order with a series of remove min operations. So this running time, it depends on the implementation. Let's see about this one. PQS, C. What is S? So S is the sequence. Okay. What is C? We call C as a comparator. Okay. We have C and then we have S. C as the comparator and S is the sequence. So whenever you create your algorithm, I guess you will need this one. What is the input and what is the output? Okay. When you write your report, okay, your final report for the team project, you need also to write this one. What is your input and what is your output? So basically, it is a kind of function, or maybe it is a kind of class. Okay. And then whenever you define something, okay, so you need to specify what is the input. For example, this one S is a sequence, and here C is a comparator. So the output will be a sequence S sorted in increasing order according to C. So P is the priority queue with comparator C, and then we want to check while S is not empty. Okay, so this symbol is not. And then E will be removed first, and then add the E and just put the empty element. While P is not empty, so remove min, and then in the S we want to add at the last section. Maybe let's see with example later. Okay. So the selection sort with the previous one, with this one, this is the sort. Okay? PQ sort means the priority queue sort with the, we call it the selection sort. So selection sort is the variation of PQ sort where the priority queue is implemented with an unsorted sequence. So we did not do the sorting at the first time. So we will just insert, and then at the end we will remove the minimum, and then we will sorting. So the selection sort, actually it will run in the O(n power of 2). Oh, this is a little bit complex. Okay, so let's see why it is O(n power of 2). Let's suppose we have S. Okay, suppose we have S, and the S is 7, 4, 8, 2, 5, 3, and 9. And then I have the priority queue, which is empty. We divide into two phases, the first phase and the second phase. The first phase, okay, we assume that every time you want to include the value, okay, whenever you want to include the value, sorry, whenever you want to include the value here, yeah, you can see here 7, 4, 8, 2, 5, 3, 9. So you want to input this value. So whenever you input 7, okay, 7 is the first. Okay, so you input 7, and then after you have the 7, you input 4. Okay, 4 will be in the next. Okay, and then after you input 4, you have 8. Okay, 8 will be in the next, and so on until you finally have this value. Okay, so 7 and then 4 and 8 and then 2 and 5 and then 3 and then 9. Okay. So we do not care when we add the element into the priority queue, we do not sort it. But after we have the priority queue with 7, 4, 8, 2, 5, 3, 9, we need to sort if we use the priority queue. And how we sort it? Okay, we need to check for every number. Okay. So 7 is the lowest? No. And then we go to the next. 4 is the lowest? No. Maybe from this one, we will check one by one. 7 is the lowest? No. 4 is the lowest? No. 8 is the lowest? No. 2 is the lowest? Yes. Okay. Then we return back 2 to the sequence S. And then after we have 2 in the sequence, yeah, we will go to the next. Again, we will check. After 2, where is the lowest? 7? No. 4 is the lowest? No. 8 is the lowest? No. 5 is the lowest? No. Sorry, not this one. This one. 7 is the lowest? No. 4 is the lowest? No. 8 is the lowest? No. 5 is the lowest? No. And then 3. Okay, 3 is the lowest among the section. Then we put 3 after 2. And so on until we have the order from the lowest value until the last value, which is 9. So we will do the sorting in the phase 2. At the first time, we will not sort, but in the second phase, we will sort. So we call this is the unsorted list. This is unsort, and then this is sort. When we insert, it will just take O1, and then when we sort, it will take ON. When we remove the minimum, we will take ON. But the overall algorithm, it will run ON power of 2. Okay. We have the insertion sort. So the insertion sort is the variation of PQ sort, where the priority queue is implemented with sorted sequence. So whenever you insert the value, you will sorting. Whenever you input, you will check what is the best position of this key. So inserting the elements into the priority queue with n insert operation takes time to the proportional to 1 plus 2 plus blah, 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 until n. And when you want to remove the element in a sorted order of the priority queue of a series of n, yeah, it will take ON. So the overall algorithm, because of the phase 1 and the phase 2, we will have ON power of 2. Okay. Now, let's see. The same with the first one, the selection sort. We have the same input 7, 4, 8, 2, 5, 3, 9. So this is the input. And then this is the place to put the priority queue. Now, when we do with the first one, you will see the difference that we want to insert 7. Okay, okay, that's the first 7. And then after 7, we have 4. Now we need to check if in the previous one, we just put 7 and then 4, like this one. But in this insertion sort, we will compare. What is 4? 4 is lower than 7 or not? Because 4 is lower than 7, then I will put 4 before 7. Okay. And then I will check the next one, 8. Okay. So when we want to insert 8, yeah, we want to check 8 is lower than 7? No. 8 is lower than 4? No. Then 8 will be at last. And then I want to add 2. So the same. We want to check for every other element. 2 is less than 8? Yes. 2 is less than 7? Yes. 2 is less than 4? Yes. Then 2 will be at the first part. And so on. Until we have all these things. So the result of the phase 1 will be 2, 3, 4, 5, 7, 8, 9. And after we have this one, you will just do the remove minimum. You will just do remove minimum and then put back all the values into the sequence. So when you do the remove min, you do not need to sort again because it is already sorted. Okay, so it means there are two, unsorted and sorted. In the unsorted, it means the first you just insert, and then when you want to remove min, you will sort first. In the sorted, whenever you insert, whenever you insert, you will do sorting. After you sort, you can just remove the minimum. Okay, so the sequence is different. However, the algorithm works the same. On power of 2. There is another mechanism. I call it, this is like the mechanism, or this is the algorithm. We call it the InPlace insertion sort. In the InPlace insertion sort, instead of using an external data source or external data structure, we can implement the selection sort and insertion sort in place. So this is a portion of the input sequence itself serve as the priority queue. And in this case, the InPlace insertion sort. So first we keep sorted the initial portion of the sequence, and then we can use swap. Okay, so we want to swap. We want to change the value. So for example, we have the pink one. We have the original value 5, 4, 2, 3, 1. Okay. The idea is similar with the general sorting. When we insert 5 and then we want to, we already have this one, and then we want to swap if we want to select the first is the minimum and the last is the maximum. So 5 will be compared with 4. Is it bigger than 4? Oh yes, then swap. Okay. And then check again, 5 is less than 2. Yes. Okay, swap to here. And then 2 is less than 4. Yes. Then 2 will be in the first. And then we have 4 and 5 at the same. Now it will check with 3. 3 is less than 5. Yes. Okay, and then check again. 3 is less than 4. Yes. And then check again. 3 is less than 2. No. Then we will have 2, 3, 4, and 5. And then finally we will go to 1. 1 is less than 5. Yes. 1 is less than 4. Yes. 1 is less than 3, yes. 1 is less than 2, yes. Then we will have 1, 2, 3, 4, 5. So we replace according to the checking between the previous element. And then whenever it is lower than the previous element, it will swap, swap, swap. Okay. Yeah, that's the concept of the in-place insertion sort. Okay, I think that's all. Yeah, I guess the other materials that I prepare is not about the priority queue. So it is about map. So it is another kind of concept of data structure. I think I will explain this one on Monday. Okay, because it is, I think I need more time to explain the concept of maps. So let's finish the class. So is there any question before I finish the class?
Professor, can I ask something?
Yes, sure.